So let us look at the first topic of the chapter 4, that is translational and rotational motion. When a rigid body is acted upon by force, so it can undergo two types of motion. One, it's a linear translational motion, or it can also undergo a rotational motion. First of all, you need to understand what is a rigid body. Rigid body is a body which does not deform at all, irrespective of the force that you apply on it. For example, if this is a body and then we are applying a force on it, and then when we apply a force on it, it should not deform. Whether the amount of force is small, large, or however much you increase, but it should not deform. If there is any such body, that body is known as rigid body. So the rigid body definition is deformation will be zero irrespective of the force. In reality, rigid bodies do not occur. But for all practical purposes, we will assume every body in the nature as a rigid body. That would actually simplify the analysis of our topic of motion. That's why we assume all bodies to be rigid bodies. But in reality, rigid bodies do not occur. There is no ideal rigid body. But otherwise, whenever a rigid body is acted upon by a force, it will undergo two types of motion. One is translational, another one is rotational. What is a translational motion and what is a rotational motion? So we will see the first point that you need to note in the translational motion is the body is free to move. If it is free to move and a force is acting on it, then it will undergo translational motion. For example, this is an object. On this object, if I apply a force F, then it would be displaced to the next position, and this motion is called a translational motion because it is translating from one point to the other point. Then it moves in the direction of the force. Obviously, when we see this object moves in the direction of the force, and also it moves in a straight line. So it moves in a straight line. The most important point that needs to be realized here is the center of the mass of the body moves from one position to other position. For example, if we take this body, the center of mass of this body probably would be somewhere here. And then upon application of the force, the center of mass of the body has moved to this position. So the center of mass of the body has moved from here to here. So in a translational motion, the center of mass of the body moves. Let's come to rotational motion. Rotational motion, the condition is the body is not free to move. The body is pivoted. That means, for example, if I have an object which is pivoted about this axis, and then if I start applying a force F on it, then this body would revolve about this axis. So condition is the body should not be free to move. It should be pivoted. So that is an important point. And then when it is pivoted and the force is applied on it, the body rotates. It is not revolve, rotate. There is a difference between rotation and revolution. Rotation is, it is above the axis. So if an object is there and this object is revolving about an object, that is called a rotation. But if the object is going around an axis which is not inside the body, then it is called a revolution. So the body rotates about the pivot. Then the point is the center of mass here does not move. If you had observed, here the body's center of mass is here only, whether even before the application of the force and even after the application of the force. For example, if this is my body and then let's say it's pivoted at the center, and then if I apply a force, then it would start rotating, and then when it is rotating, if you keep observing, the center of the mass of this body always lies at the same position. It is not moving or it is not translating. So in a rotational motion, the center of mass does not move. For example, the example for the translational motion, you can take it as a bullet which is fired from a gun traverses the path of a translational motion. So the bullet is here now, after some point it will be here and it will be here and it will keep on moving. Whereas the rotation of the earth can be taken as an example for the rotational motion. because the earth rotates about its own axis, so it will keep on doing this. So that's a rotational motion. So this is the first topic of the chapter of force.